In this particular part, we're looking at a study in which the proportion of people who were satisfied with the way things are going in their lives is 72%, 0.72. And where we're told that we have 100 people in a random sample, and we're asked to complete some information about this. And the question was on part C. So when we describe a p-hat distribution, there's two things that we need to check. First of all, we have to check what's the sample size in relationship to the population size. So we always want the sample size, that's a lowercase n, to be less than or equal to 5% of the population. Well, we're assuming that here we've got a population of people, so we're assuming that's a big group, so that's okay. And then we've got the other thing we need to check is NPQ, and Q is the same thing as the complement of P. In some places you'll see N times P times 1 minus P. I just write this Q. So NPQ has got to be greater than or equal to 10. That's the two things that you have to check for a p-hat distribution. Then once you see that it satisfies that, then the mean of a p-hat distribution is the same thing as the probability of success. And the standard deviation of a p-hat distribution equals the square root of P times Q divided by N. So that's what we're doing here in part C. So we want to verify that, yeah, the sample size is no more than 5% of the population, so that's okay. That part's checked off. The other part that we've got to check, what is NPQ? So we're multiplying 100 times 0.72 times 0.28. And when we do that arithmetic, that gives us this 20.16. So that part's okay because it's greater than 10. And the distribution of the p-hat is approximately normal, so it has this bell-shaped look. And the mean is the same thing as P, that was given. And then to find the standard deviation, the second answer here, we're going to take the square root of 0.72 times 0.28. That's P times Q. And then we're going to divide by the sample size. And in this case, the sample size was 100. And when we do that arithmetic, then we end up with this answer, 0.045. Hope this helps.